Okay, lesson 3.5, complex rationals. So to warm up, let's use the -1 method to negate this denominator, giving us common denominators. We get -1 extracted from this expression, which gives us 2y minus 6. Now this -1 floats up to the numerator and negates the 9. Now we have a common denominator of 2y minus 6. Putting both of these fractions together under the same fraction, in other words, they're sharing a denominator, we add the numerator. So it's 3y minus 9 over 2y minus 6. Some people might stop here, but you can actually do a little more. Let's extract the greatest common factor from the numerator, extract the greatest common factor from the denominator. As you can see, these will cancel out, therefore giving us our final expression as 3/2. To simplify complex rationals or complex fractions, rewrite the entire expression with a division sign. Follow all previous skills you learned, such as KCF, keep, change, flip, and finding the least common denominator when adding or subtracting fractions. Let's take a look at our first example. Here we have this complex fraction. Let's rewrite the entire thing as a division problem. So it's 1 minus 4 over x divided by 1 minus 2 over x minus 8 over x squared. So you have previously learned how to add and subtract rationals, and so we're going to do exactly that. So let's look at the first expression first. We'll put a 1 under it, so we're dealing with all fractions. Next thing is we want to find the least common denominator. So here we have 1 and x, so we know the least common denominator is x. That means I need to multiply this fraction by x in the numerator, x in the denominator. Here we have x squared, x, and nothing over here. Well, actually there's a 1 over here in the denominator, so we know that the least common denominator is x squared. That means we'll multiply the numerator and denominator by x squared here. We only need to multiply 2 over x by x, and 8 over x squared does not need to be multiplied because the denominator is already x squared. So now that we have this, let's go ahead and rewrite this sharing our common denominator. So here we end up with x minus 4 over x divided by x squared minus 2x minus 8 all over x squared. Next thing we want to do is keep, change, flip. Remember, we have a division here, so we must multiply by the reciprocal and then factor. So x minus 4 over x remains that way. We'll change division to multiplication, and then finally we will reciprocate this, and within the same step I'm going to factor this trinomial, giving us x minus 4 times x plus 2. And as you can see, the x minus 4 cancels with the x minus 4, and the x cancels with one of the x's up here, and therefore the remaining numerator is x and the remaining denominator is x plus 2, so our final answer is x over x plus 2. Let's look at this example. We have, first thing is to rewrite as division and find the least common denominator. So here we have x squared y squared. The least common denominator is the product of them both. We need a y squared here. We need an x squared here. Over here we have a y and an x by itself. We need an x over here, and we need a y over here. Now we have our least common denominators. Let's go ahead and rewrite this so we're sharing a denominator. Y squared minus x squared all over x squared y squared, and x plus y all over x times y. We're still looking at the division sign. So the next thing we need to do is keep, change, flip, and factor. So I have recognized that y squared minus x squared is a difference of perfect squares. That gives us y minus x times y plus x. And this will come in handy because we get to cancel the y plus x and the x plus y. We also get to cancel one of the x's and one of the y's. So the remaining numerator is y minus x, and the remaining denominator is x, y. So our final expression is y minus x over x, y. The last one, we're going to work with this because we have a binomial in the denominator, which always makes it a little trickier, but it's the same concept. So first thing is rewrite the division, rewrite it as division, and find the least common denominator. So here we have x plus 1, and we have x over here. So we know that we need an x plus 1 factor here, so we'll multiply by x plus 1, and over here we multiply by x. Over here we have x minus 1, and we have x, so that means we need to multiply this denominator by x minus 1 and the numerator by x minus 1. Over here we're missing an x, so we multiply these by x. Here you must distribute. Luckily we're distributing a 1, which keeps everything the same. So it's just x plus 1 minus x over x squared plus x divided by 2x minus x plus 1 all over x squared minus x. So now we've written it as a shared denominator. Finally, let's keep, change, flip, and factor. So as you can see, the x squared plus x gets factored out of x, and the x squared minus x, we factor out of x as well. And conveniently, we will see that the x and the x cancel, but nothing else cancels. So the final expression is x minus 1 over x plus 1 quantity squared. There's the lesson. Best of luck to you.